All right, welcome everyone for cloud computing and big data, parallel and scalable machine learning and deep learning. The topic of today is software as a service with very powerful functionality and applications, as you will basically explore throughout the lecture today. We also see it's largely based on the building blocks we learned the last times with PAAS, platform as a service, and also, of course, underneath infrastructure as a service a lot. So in a way, we see today the highest level of all of these stacks that we discussed in the couple of last lectures. And before we go into the material of lecture 10, let us just briefly review what platform as a service was and basically how it relates also to infrastructure as a service. So the last lecture was really thinking about an analogy, which was largely these Lego bricks. And we have said basically platform as a service means I have a developer perspective or a web application provider and developer perspective. Someone who's not just, let's say, using it for the sake of getting a business case then for instance, writing builds or doing customer relationship management in some business company. No, what we talked about was basically I will create something new from services which are already existing. And the idea here is that you don't create everything new. And I think this is, of course, a key ingredient anyhow today in software development and software engineering, right? This is what also Matthias teaches, of course, libraries and software engineering and so on. But also think about that this goes one step further, because you always have to think about here, we always think at scale. So scalability is inherent in the design, meaning that the more customers you have, the more your infrastructure has, of course, a load to digest. And with this, you have to grow. And this could be, as we have seen, for instance, in Angry Birds, a quite substantial growth, which started essentially as a totally not known company with some failures on the way, and now being extremely successful that they even are movies about this. It's an interesting development, and this was fueled with the Google App Engine that we have seen. That is just one example of services that you can use. And it's also important to think that you basically have these Lego tools all around and you have lots of them, and you want to build them together. And this is, of course, one part of the story of PAAS. So having these Lego blocks to your availability and that they scale. But the other part is what we discussed as a plate, so to speak, where you put the Lego parts on. The life cycle. We know that software development never ends. There's always maintenance. There's always a new version. There's always something to think about. So in this sense, we rather think about a whole life cycle of software engineering for building apps, then perhaps upgrading new levels come in. Then I want to deploy it in the cloud and of course test it with some, let's say, test users first before I really publish then the new models. And all of these lifetime management aspects of software are really good supported as well as platform as a service. And that's why many companies actually think about while developing applications, which is then also not their main concern. What we have seen in Philips, right? It's not their main concern to develop software. Philips does Lightning. So why they basically should have huge computing infrastructures in-house, a plethora of developers and administrators that deal with the scalability. We have seen that the Philips Hue, which is this interesting idea of steering up and down and left and right and coloring and whatever your light bulbs at home, and many other devices actually I didn't cover. This is all really an interesting business, of course, but also requires a substantial IT infrastructure in the back. And that's why Philips has then chosen Google as one part of the service provider. But we have also seen that more and more providers pick maybe different cloud providers for different services. So you not only stick to one. And this has led to some of the problems of PaaS. And in generally, maybe in basically the idea of having these new products created from PaaS services. And this is a huge lack of standards. So there are essentially no real standards. HTTP, of course, is there for the rescue, so we know how to access it and in a very standardized manner with REST services. But as soon as it comes of transferring things from cloud A to cloud B, we are in sort of trouble. We have the S3 de facto standard from Amazon about storage, which certainly helps, but we have seen there are many other problems on the way. So one movement which helps a little bit this migration from Cloud A to Cloud B while having this missing standards are containers. And I will touch on them again today. So things like Docker, things like Singularity. There's also UberCloud that we will discuss today, but there are many different ones. And the idea there, as we learned and that you see here on the bottom left, is that you have a little bit an easier design when you think about comparing it to virtual machines, where you always carry around, let's say, the big bulk of the guest operating systems. But perhaps that's not always needed. In the end, what you're interested in is having an application running and some binaries and libraries that can be rolled out in a container runtime that may be installed in different clouds. So you shift a Docker image basically from Google to Amazon, and it should work. And you don't care what operating system now finally make it work. All you're interested in is that you have your container basically there. But as I said earlier and in several lectures, and I will talk about it today again, containers grow so significantly in relevance that I will have a whole lecture about it. So it is going to come in 2 weeks, I think, so we will talk there much more about it. I picked the last time a very specific, or basically 2 specific ideas of PaaS services, while there are probably hundreds, if not thousands, available. And I think one particular one that really stand the test of time and were also helping a little bit the big data movement were these so-called key value stores. And there was really a development that you saw that SQL was always the modus operandi in databases. So essentially, over 90%, everybody was doing relational databases at some point in time. And then suddenly, with having frameworks like Hadoop, Spark coming around, more, let's say, frameworks and use cases like machine learning that rather read from data than just write. And immediately, if you just, let's say, optimize a system for reading, you can relax some consistency requirements that basically are in relational databases. For instance, the first name always has to be filled. Because that's the field from the SQL database that has this constraint, it should be not empty. And they have lots of them, just as one example here, concerning also the illustration that you hear on the top. So meaning for NoSQL databases, one key development idea was relaxing those consistency and relaxing the requirements of having always an SQL schema, so already having all attributes set in stone for a database. You see this very well here in these 2, let's say, interesting different people, which have different information, and that's just real life. If you look in a database, you see rarely everything is always perfectly filled. Look at Facebook profiles. Some expose the phone number, some not. Some not exposing their emails, some do. So everybody has a different way of what to expose. And the idea is really thinking more about, again, bins, about values, but of course one key which is used then for performance reasons, and according to this key you can then map with different approaches. We have seen hash approaches, hash functions, but also different ideas with document stores, with JSON encoding in different implementations of NoSQL. And these really become more and more relevant. You have seen HBase is often used within the MapReduce frameworks, essentially to really, like in Facebook, to do something very in a high performant and parallel way. So of course, this is also, this relaxing of the constraints enables us also to think about that this is of course a bit more easier to do it in a parallel and scalable way, to have the database more or less also distributed. Now, thinking about another kind of cornerstone, which we unfortunately cannot cover here very much, but we have colleagues in the University of Iceland, like Hafstein, for instance, who is quite an expert in natural language processing and has also machine learning courses to come that cover this. But just that you know that, of course, PaaS services here are also there, order of magnitudes available, and they're very successful these days. Even if you know the cloud translation of Google Translate is sometimes questionable, think still about what it means to have at least a grip what it means. And then when you have all the other tools we discussed, from speech to text, text to speech, also if they're not perfect, think about that you need that maybe for your product that you want to do in a PaaS manner and then expose as a SaaS, as a software as a service. You still need lots of, not only developers to do all this, to create the software, you need also machine learning experts that actually create the NLP models. There may be some open source ones around, but the question is, are they already supporting 125 languages? And maybe you want to have your product exposed on the global market. So you see, it has, let's say, advantages and disadvantages to use a cloud. And one of the major disadvantages you know by now, I hope by heart, is the costs and the price. Don't overlook this fact, right? The indirect costs everywhere. So it's good to really monitor this. And of course, the tools provide monitoring tools for this. But sometimes I think people overlook the fact that these things add up, even if it's just a couple of cents or just $28 for a GPU per hour. But what if you really train a big model, which requires lots of hours, and I need it on a daily basis, and then quickly costs can grow. Right, and from this, we now basically transfer to the, let's say, really product that is at the end of the chain, building on top of the infrastructure as a service, and then subsequently on some of the platform as a service offers, which stick together the Lego pieces to bring really interesting, cool software into light, which usually has one common goal in mind: to abstract from everything you learned in lecture 8 and lecture 9. So of course, you never expose the costs that we just discussed to your end user. You just have a subscription fee. And in this subscription fee for your product, you need to budget for your underlying infrastructure. You basically buy in from Google or Amazon or Microsoft Azure. So we will talk about exactly this, thinking about benefits, what SaaS has. So it's relatively easy, that you can really have an interesting multi-tenant architecture with horizontal scalability, where again, virtualization enables a lot. So you again can very quickly grow with your customer base. You have lots of different services. So in a way, we have here lots of different success examples, but we also have to think about that with customer relationship management being just 2 examples. You can go to enterprise resource planning. You can go to different areas in business. This software life cycle is really, or how software is delivered, has been fundamentally changed, and we will have a look on this. So if you think about it, at times 15 years ago, you go to a shop downtown to get a package where your software is in, right? Think about this. And then you were quite, annoyed that the software is not there because the software package was sold out. So you have to wait a week until, Windows 98 or whatever is, sold again, or your favorite game maybe is the same way. Now, and nobody is almost doing this. Basically just, it's more or less becoming a kind of, showing what's available kind of idea than rather really using it. Essentially saying they sell you empty packages with a download link where you can download it on the internet. And of course, which makes sense because you see we have lots of updates, we have maintenance and so on. So with this, a complete new pricing model with licensing scheme came into light, which we will also look in terms of subscriptions and so forth. I also picked a little bit the Amazon Sagemaker here, being a machine learning and deep learning course that we will review also briefly, of course, again, in terms of pricing. But it is a really representative and very powerful IDE for machine learning, which can do a lot. But you also, of course, have to pay the price when you want to use GPUs, of course. So in the second part of this course today, or in this lecture, we will basically then go to some advanced topics of SaaS. Of course, I could go on and discuss, what are different products created after the SaaS idea, but you will see more and more in the internet is essentially a SaaS service. And the point then with this advanced SaaS topics is also to understand what are the benefits basically for these software providers. You can easily do cross-selling. Basically, for instance, we will look on Zoho. It's a very good example of being very powerful in customer relationship management, but now extending to all sorts of different business sectors. In the same way for Google or Microsoft. Then we will have also, of course, to see on some disadvantages. You have advantages, but disadvantages maybe also for users that have security concerns, that basically also are a bit afraid that the data is locked in. What happens if suddenly, your cloud provider is Chapter 11 and, will just bankrupt? What happens with the data? Who owns the data? Can you still access it when the services are all down? So these are questions, of course, which raises some concerns we have to review. Also in the light of, national boundaries, US versus Europe. There are several words you should know a little bit, although we are all not law experts and we always should consult them if needed, and we are in trouble in this. But you need to know names like Safe Harbor, GDPR, and of course then also the Patriot Act that I will reveal. We see more and more also that these systems we have in internet modus operandi, so to speak, will be intertwined. So social media features, social features, just having messaging. Yesterday I was just in another 4 hours, tutorial about machine learning for a specific set of physicists. And what came up was a social tool for coffee breaks. And this is now getting integrated everywhere so that people, have interesting features. There are very specific niche markets that you can now target as SaaS because you don't have the rollout anymore. You don't have to have the shops downtown that sell you some packages. You don't have to agree with this, let's say, different people downtown that sell software. Please use also my product. You have the internet. You can be found, right, using a smart search strategy. So we have there safe contracts, so law, specific aspects of law again, that you can book, or engineering clouds we will talk about, which are very, let's say, niche market in computer-aided engineering, for instance. So we see lots of interesting happenings by having these SaaS topics more and more explored. We will look, of course, throughout the lecture to commercial cloud examples, because that's what you face when you face a job market like Microsoft, Google, Amazon, Conga, and UberCloud, for instance. But I also want to leave you on the table here something, what you see, what is kind of a benefit as a researcher in a way. And this is these free EOSC services. I was talking about the European Open Science Cloud before, which have a plethora of services for researchers free of charge. And I think this is, of course, one of the benefits being a researcher, also having GPUs for 0 cents and being cutting edge, as actually Rocco and also Gabriel in their deep learning were also alluding to, right? They don't swipe the credit card. They can do and use GPUs for research and engineering. Finally, I basically close up this with some disadvantages, of course, which are here and there already inherent. And with this, we fulfill a lot of promises looking behind clouds from different perspectives on the IAAS level, PAAS level, and also, of course, the SaaS level. So when we understand the SaaS benefits, let's quickly reveal again on which level we're talking now again. And basically, you have the same situation that we discussed before with PAAS. So the boundaries really here are not fully clear. So basically, when I'm talking about Jupyter, right, you can say, when you talk to some of them, you would say to some people, well, Jupyter, that's a platform. You can do deep learning on it. You can do some business cases on it, some data analysis on it. That's a platform for me. For others you talk to, it's just a software that is ready to run, right? You click, you have a Jupyter notebook. And of course, the scripts are there already, so you just execute. So you see here also, it depends, of course, a little bit how your software is designed. We will look at the Sagemaker for an example of this. But basically, you have also here the point, there are no very clear boundaries. It's often a little bit of interpretation. But what you always can basically take on for sure is that as most as it is possible, the infrastructure aspects of it are hidden. So in very rare cases, you really have to choose then the particular infrastructure it should work on, except it should be on performance when I say I want to have, for instance, an accelerator or not. And of course, I want to review the costs with it, which makes a significantly difference, if you remember, not only in speed, but also in costs. And with this, we have our interesting overview here again from the last time where we said we have IaaS, which is quite clear to us, storage, service, networking, also, of course, compute resources. And what basically was added by PAAS was all these development environments to do, proper, interesting geographically dispersed development, even with teams, but also adding the idea of analytics and analyze your application for internal purposes or for your business models, right? So all the business intelligence ideas of services. And what's now added from the SaaS perspective is really that you don't care about any of this. You just want to have an application. You have a hosted application that just has an app usually, or a desktop application that you can really use. And you basically have to just pay, right? That's what mostly all of them have in common. And also you will see behind Google, although it seems free, I will shed light a little bit today, of course, where are also ideas in Google Maps why it's free and why there are ads. And I will talk about this throughout this course. The idea, of course, is getting as easy as possible, right, to get to the software. And if you now compare that, as I said in the beginning, to the traditional software that some of you may know still, going downtown, basically in a big supermarket or in a shopping center, and I want to have my physical copy of a certain software, were actually even searching sometimes or going to different ones because in some shops it was sold out. Then you were very eager to get the game, you were very eager to get the operating system, the new one, and then it was basically not available. And then you go the next day and the one after next to just get it. And you know, this is a interesting time if you compare that, and you have lived through this when you compare how it works today. Today we have really a SaaS multi-tenant architecture, as people would call it. So you have different users on different levels that you can serve with different licensing schemes. There are unbelievable many benefits, of course. You have a single version that you basically have in the cloud, and a configuration you can basically always change, and the look and feel and also the kind of technical aspects behind it are hidden to the user, and they don't have to care probably about API changes and so on. You have to be a bit careful in this. Of course, usability has also one aspect of it, which is actually change of the UI. So if you change your UI again and again, you will see that your customers get also angry. The second part is it comes with nice management philosophies of basically serving the software development lifecycle, which is underneath. So you could have a very nice exposure of pre-releases, beta products to your, let's say, hardcore test users that you trust for 10 years, that you give, let's say, a specific cloud instance just for these selected groups of your customers to test a new version before you basically publish it or put it live. And lots of other aspects, like we already discussed many times, that come automatically, of course, with the virtualization approach, like the data center approach, having basically scalable SaaS models, which enables you more and more users on demand as you go. So when you think about this now, here you see that a little bit on the right. Again, also even on the SaaS level, we have the applications, which play a huge role in, of course, getting revenues, right, in all of this. And you see behind all of these nice fancy icons I put here, there are also massive revenue streams we will look at. And why this, of course, this is just beautiful and works nicely. And let us just have an interesting example here from a customer relationship management system we will look along the way, called Zoho. It's a very large one, won several prizes. While many of them actually won prizes. Also Freshworks is a CRM system that won prizes. But basically it's a huge market that we will reveal. So how do they do that? So you see here, they could easily exploit the virtualization, as I told you here on the right-hand side, by having these platforms already created in the platform as a service manner. And then they have their virtual solution A and their virtual solution B. And here's just the example how Zoho is doing it, right? They have this virtual solution E, which is really the production Zoho environment. Everyone who is having an account there that is buying a subscription has access to it and can work with it. But they have also a virtual solution B here, which essentially also horizontal scales with the number of users, right? That means the more users you have, you maybe have more and more virtual machines on more and more physical devices running without everybody ever knowing, because of course it's only accessed through one website. But these two virtual solutions are basically, they're put there in parallel and called also Scale. And they can test new functionality in the solution B while the whole production is still scalable, is still working fine by exposing this interesting infrastructure as a service, which is then exposed with different building blocks via the platform or virtualized platform as a service models. So this is just one idea what many people really do these days. Having this horizontal scalability is, of course, enabling for SaaS lots of different benefits that you don't have to think about anymore, to which shops you basically go to have more and more of your products put out. Rather, you're thinking more of advertising, right, in the internet, so getting more users, and basically your infrastructure underneath is growing with it. And when we go there in everyday life, you will see there are lots of these clouds that have that inherently. And we talked so much about Google, Microsoft already, so I want to pick some others also to show you the game, right? Salesforce, customer relationship management is one example. There is a movie, so I don't put this too much into light. You can look the movie at the end of this first part, but there are others like, for instance, CRM systems like Zoho. There are actually Salesforce, Freshworks, there are lots of them, and some of them that even are doing more than that. You would say here this Dolly bar is not only CRM, it's actually also enterprise resource planning. So what is it? In the end, it's basically really managing the interaction through the whole customer life cycle. But of course, you can imagine going through this life cycle, you have lots of big data along the way. So every customer history is plotted, every interaction, phone call, email is actually accessible. So you can learn how the customer is working, how the customer is fulfilling his needs to give him, of course, recommendation and offers. We will look on this on the AI models. And the overall idea of the CRM is really to improve the business relationship, keep him right to your business, not let him away. And often this also means today really seamlessly connecting to social media and all forms of channels. So you don't have just a Facebook link, you have the whole plethora from Pinterest, Instagram, Twitter, and YouTube up to, several ones which are maybe very specific in different markets. And it's a very interesting thing that has a huge market. But enterprise resource planning is another big field where it's a little bit different because you rather think about your own enterprise, your own business, and what it is related in terms of the whole life cycle of, for instance, creating and shipping a product. So more on the real idea of thinking manufacturing, service delivery, but of course also including things like marketing and sales. Your inventory, right? Do I have the right time, the right resources to really construct or manufacture something? So all of this is today supported by so-called enterprise resource planning, which would be a huge lecture again. I can put just on ERP systems, and I picked here CRM, not to focus only on it, but to really, again, go in some concrete examples before we stay too high level in this. And so we pick CRM from different viewpoints and see how interestingly this is, of course, today for companies that strive like Zoho as an example, but also Freshworks that keeps continuously growing. Actually was known 2 years ago as Fresh Sales. Also explains the fact that these really are growing with lots of interesting customers which are now have given input and basically also accept the SaaS model, right? We don't question that anymore. Nobody really wants to go downtown, get a package for a CRM package anymore, and then wants to have to do updates again and again on themselves. We live the internet right now, and this is of course just fueled by it. Just to understand why are there so many players in this business? I put here one figure, which is admittedly a little bit old, but the real revenues is never known until a couple of years. But here in 2011, you see the market just in SRM and SaaS is essentially the largest SaaS market that is available, is $3.8 billion. So of course, that's why basically every company in a one way or another needs something like this, right? And also you see, when you look at this figure here, that is also interesting to see which different parts it covers from the business processes. It's basically going from communication channels over to the analysis of data in the middle here, to different, let's say, branches in your own company: marketing, managing, selling, and support. So it covers, of course, huge areas of a company, and with this, you can imagine everywhere are benefits that maybe can actually contribute to this revenue in 3.8 billion. So let's look at some of them when we go more deeper in some examples. So as I said, interesting is, of course, the kind of idea of the CRMs in different ways. And I think Freshworks is a very good example showing how they transformed in the last 2 years from just thinking about sales, also integrating the whole marketing, which is an important part of it. Now, basically having lots of communication channels, sales and marketing channels. So this is all more or less intertwined these days with social media. And you have an overview about all of these different channels together, right? So in a way, you can think with one click, you know everything what is said about this person in Twitter, in Facebook. You know everything what this person has actually bought the last years for this company. So everything is essentially just one click away, and including your email history with this customer, which is of course one part of the story, which is very clear, but of course already requires that many of the, let's say, interfaces are actually working together in all of these different business branches. Now, the other part of the story, which is quite interesting and fascinating, you see today, almost everyone is now including artificial intelligence. And if you remember in one idea, we said, this is machine learning, deep learning, and here you see it's essentially saying, here is a recommendation that looks like a good fit for this particular product, right? You can imagine this is, of course, also flourishing. This was the example that I basically personally, even though I use CRM Zoho for my personal, task management and everything. And we will learn more about this when we think about how this actually stored with graph databases. But it's really with one click, I can go to all the social media profiles. Think about you're a marketer or basically also recruiter, right? All of this is very easy today in this kind of CRM systems accessible. And I'm actually putting here this in black what person it is, but you can imagine you get more and more details about these persons. So when you think about the modern software delivery model we discussed, this is also important. Thinking about that we have these benefits really. We have from the user perspective, surely some benefits. This on-demand software, I can, just in the evening, I just decide I want to have this product. I go to the internet, I pay it. I have flexible payment options. I don't need some big new desktop computer to buy unless it's maybe the perfect game. Usually it is coming somewhere via the web browser on a lightweight, thin client fashion. And I don't have any upfront investment in a big server or software maintenance if I'm a company, and I can grow, like for instance, with the number of users I put to my customer relationship management. So basically as a company, I start with maybe just 5 people, but can see if it works, then I can roll it out in my whole company with 100 users. Not a problem, the subscription models allow it. So then the software provider perspective, the other way around, you don't have this physical distribution of software anymore. That helps a lot. The customer data is stored in the cloud, so you can learn from the customer data very easily and quickly. You have discounts, automatic renewals, so you keep automatically the customer without knowing. You have the credit card, you just use it every year, and maybe the customer doesn't even use the service, but is still billed for it. So they are interesting models, and of course today almost everyone, as I said, is also augmenting their kind of services with powerful AI capabilities. Now, when you have the modern software delivery model, you have the service level agreements that you also have to think about. So it sounds all so easy, but all of us, we click away when we do Amazon, when we do others, AWS Educate, we click away these terms, right? And of course, these terms are loaded. And you see over the last 10 years, they go longer and longer and longer because you have, of course, also several specific law aspects within, which is one part of it, but also thinking about that, of course, you have to specify what the people for lots of money also can get, and have to monitor also that, you deliver this, because otherwise, because money, and it's a contract in the end, an online contract, then you basically also are in a law territory where you can be sued if you don't deliver, depending on a certain quality of service. So this is also an interesting part, touching, of course, on data integrity, privacy, security, data protection. Now, when you think about traditional versus SaaS licensing, I think all of you have done this and seen that almost everywhere. So I don't go long into this. Instead of just having an upfront cost, I buy this game, I buy this product. I can now do it monthly. I maybe get some, better deal if I do it on a long term. And also maybe I don't use all the services I have in the cloud. There's always this kind of different user growth, like Pro or Enterprise edition, really for companies or for personal use, or maybe the free version for a couple of things to learn about this, what Zoho here is offering, up to an ultimate version, which is really optimized for large enterprises with a minimum of 100 users. So you see, essentially, there's a huge way how you can use this, what you basically put in terms of services to be available in the CRMs, and it's just in massive uptake of this. Of course, we can go more and more flexible. You see just 3 options for Freshworks. You see already 5 for CRM, and of course you can go on and create your own licensing schemes. Now, from the provider perspective for CRM, of course, often there's a free trial, freemium models to get you hooked. As I say, as a university professor, I am allowed to do this. I'm not working for these companies. Of course, one idea, think about this, is to get you hooked on this infrastructure so that you keep, working there, even if it's not anymore for free, right? And then provide your credit card. I mean, everything is basically going to this, from games up to CRM systems. And I said, by far an interesting approach is also for machine learning now the Amazon Sagemaker that I already alluded to several times. So you know by now, it's a Jupyter-oriented tool that you can get there, but you get much more. You have basically an integrated development environment for machine learning, which is extremely rare in that quality. So if you use it, you will be amazed how nicely this all integrates together. Seeing people maybe from Eclipse, with Eclipse plugins, they work all nicely together when you develop software, maybe Java, C++, it works for many different languages. You have the same here in a way for the machine learning lifecycle. Lifecycle means I'm not having just a Jupyter notebook I'm interested in. Of course, that's key and relevant because there's my code. But what I'm relevant is for instance, also in the experiments, I want to track the model performance over time, right? You can do this with tensor boards and so on, also manually if you want, but it's really cumbersome. And in this IDE, you have all its widgets, more or less, that you can integrate here. And then, of course, you track all your different models, all your jobs, your computing in one view. And it's really customizable, of course. And with this, you have really a very powerful tool. And it works for labeling of data, building models, training and tuning up to the deployment with interesting tools with augmented AI. So very powerful model. But what could be the drawback of that? Now, if you think about what we did and what also, Rocco was in his lecture alluding to, and then I repeated this when we thought about our paper we published using, this ResNet 50 with 96 GPUs, cutting edge GPUs actually. But even what we explored already a little bit with the MNIST now, that CPUs for that with the CNN are basically not really, so with convolutional neural networks are not really high performance, right? So what I need is here accelerated computing. On the left side, you see what it means to use the studio notebooks from Amazon SageMaker, basically with normal traditional CPUs, but deep learning is hardly possible with this. So the price still per hour is quite high, but you get a very affordable and nicely machine learning environment for it. But now if you think about if you use cutting edge GPUs here, $28 for 1 per hour. Right? And this is, of course, something where you now seriously have to consider what it means when you have really advanced computing models. It's very easy. It's very good to use SageMaker, and it enables a lot. But of course, always think about, again, the pricing behind it. Of course, this is a business model. And not forgetting that by creating Amazon SageMaker, also Amazon Web Services developer have a lot of things to do. So they have to hire a lot of developers to make it so streamlined and seamless. So in a way, that's really all I wanted to say for you. You know a little bit more about SAAS now. Of course, you have to see that many of those are really a black box how they operate, right? We cannot just knock, Salesforce, please let us show you whole architecture, because it's in a way their business. Some of them have a unique selling proposition in this. You know how or why people are choosing, for instance, Freshworks CRM over Zoho CRM and things like that. And also Salesforce has this, if you look on the work.com strategy, also nicely integrating the human resource aspect in it. So, and this is something what you of course can look here in the YouTube video, and we break here for 10 minutes and then return to the second part.